Thank you. It's great to be here. Thank you, Duan. Thank you to the FIL Foundation and Protocol Labs team. Thrilled to be here. I'm Tom Trowbridge, co-founder of Fluence Labs. We are a peer-to-peer compute protocol and application platform. You may recognize some of these investors. I'll obviously point out Protocol Labs, very important investor for us and excited to be partnered with them. What is peer-to-peer compute? So that may be academic, but I just want to level set with the audience here. It basically is compute without centralized hosts or the cloud. And where does most compute happen? It happens in centralized hosts or the cloud, right? So that is, a very important limiting factor in compute today. How do you do peer-to-peer compute? There are basically two options. You can either do on-chain smart contract compute, and that's what most people think of with peer-to-peer compute, or you can do general purpose compute. And it's worth realizing that the smart contract-based compute is slow, it's redundant, and it's expensive. And it's also a tiny fraction of the overall compute. It almost doesn't even register, and I'm going to show something later about that. So we're focused on the general purpose compute, which is basically 99% of the web. Importantly, also realize that where does IPFS store its data? It's not on chain. IPFS uses blockchain for incentive mechanisms and to compensate, but it is not stored on chain. So general purpose compute is where we think the future is. Let's back up for a second. What's wrong with centralized compute? Well, you've got companies that do it, and then you run the risk of censorship. I think everyone is aware of people that have been either banned or shadow banned on Twitter, and that's just one example of the type of censorship that any particular company is completely within its authority to do, and frankly exercises a lot. The other is clouds, and with clouds you have massive dependency. And so AWS, Azure, and Google control 60% of the cloud. There was actually something regulatory released recently in the UK where they have 81% of cloud revenues in the UK are those three companies. And when that's the case, the companies on the cloud have massive dependencies. Next issue, which is related, is deplatforming. Centralized applications can kick anybody off, and clouds can also shut off applications. Now, why would Twitter shut somebody off? And why would a cloud shut somebody off? Government. When companies get large, governments have to get involved, and always do. You can go back to any industry. The larger it gets, the more relationship with government it has. Whether it's media, whether it's railroads, it happens throughout history, and it's just the way things generally operate. And so we've seen government censorship drive WhatsApp decisions and censorship in India. We've seen Parler taken off. I don't think people's lives have been impacted negatively by Parler being deplatformed, but it shows what governments can drive, and that more and more revelations come out, it seems every week, about the government influence on all of these platforms. But also, what's important is what we don't see, which is closed systems that do not create, where innovation hasn't happened that otherwise might have. And so Twitter and Facebook closed off their APIs around 2018. Farmville, you can think of all the Twitter applications that used to exist. Everyone in this room, think of the innovation which has happened since 2018. If those platforms were open, it's hard to conceive of what other applications and innovations and usage we might see on those platforms. And so that's within their right to do, no doubt, but it's hard to imagine what could have happened if these platforms had retained their open APIs and made it safe for developers to build on them with confidence. And that's an issue that is really core to centralized compute. Also, deplatforming risks don't exist just in Web 2 companies. Web 3 companies, a lot of them rely on the cloud right now. The cloud, by the way, is not some puffy, white, benign cloud. I like to see it as a storm cloud with lightning because it's dangerous. And that's how I will always show the cloud. Infura relies on AWS, as we know. And centralized, even a lot of applications we know, like Snapshot as an example, rely on centralized servers. And it's no one's fault, it's just that peer-to-peer compute hasn't evolved to a level that people are comfortable deploying it. And is this the internet that we want? I don't think this was Tim Berners-Lee's vision for an open internet. But the problem is that the internet rewards scale, and the winning businesses become massive. And when they become massive, governments have to be involved. And the companies have to listen to shareholders, have to grow, and have to avoid jail, right? And so when you have those type of incentives and the governments recognize the strength of these companies, there is going to be a relationship. And so that is something that is sort of inevitable. And so the question isn't how do we stop that from happening, it's how do we create an alternative that basically governments will not have that same leverage point to access. And so how do we get here? We got here through basically an evolution where people started hosting internally, were dragged kicking and screaming into the cloud. Many companies resisted for a long, long time going into the cloud. I know myself and lots of others were very excited to invest back in 1998 in data centers, and that was way too early as companies hemmed and hawed about moving to them. Now, that's the default. But peer-to-peer platforms are the next evolution and probably the final evolution. So why is open peer-to-peer the future? It's infinitely scalable, it has higher security, and it has better resilience. So let's talk about each of those in turn quickly. Scalability. If you have a hardware marketplace, you can respond, and the market globally can respond to price, demand much faster than any centralized company. And so anyone can contribute hardware to the network and turn it on or off given price signals. I don't think anyone would think that a global network is less efficient in responding to demand than any one company, no matter how big that company is. You also can tailor offerings with a marketplace to users far more specifically than one company. And security. When you have a peer-to-peer network, it's far more censorship resistant because there's no one owner. It's a network, and anyone can host or use. And so there's no legal entity to compel. There's no management to threaten, no directors to influence, and no shareholders to pressure. So you're far more censorship resistant, and you're also far more hacking resistant as well. I think people haven't focused as much on not only can companies be vulnerable to explicit government influence, governments have infiltrated companies. And Twitter has been a long-standing case with Twitter where Saudi Arabian agents have effectively infiltrated Twitter to dox Saudi Arabian activists, leading to jail for several of them. Resilience. I was thinking here about resilience in terms of the network outages that we've seen happen with Amazon, with the cloud, with Facebook, et cetera. But there's also other kinds of outages, which are deliberate outages. And again, when you have a centralized compute and centralized network, it's far easier to shut it down. With a decentralized network, you're protected from both inadvertent human error, but you're also protected from explicit, deliberate attempts to shut down a network. And so that, I think, given what's happening in Iran, happening in many places around the world, is bringing to the forefront the absolute need for peer-to-peer networks. Where do we stand? Well, we have peer-to-peer networks in payments and in storage, but we're missing the compute layer. And let's talk about traction. For peer-to-peer payments, I think everyone is very familiar and knows that Bitcoin and Ethereum and many others currencies have now a very long history, significant assets, and lots of volume. That problem or that use has been taken care of. Storage, we're all here learning about IPFS and Filecoin's terrific success in bringing on usable storage with over 200 petabytes of data stored and much, much more coming. But what about compute? And the compute market's hard to gauge, but it's somewhere between 100 and 400 million or so right now, growing to about a billion in 2030. Is that a big number or a small number? Well, the cloud last quarter did 126 billion in one quarter. Now, this is not exactly fair because it includes content delivery services, it includes storage, it includes a variety of services that are not apples to apples with just smart contracts, but you could quadruple it or cut it by 10 and it still shows how incredibly tiny smart contracts are in comparison to the cloud. And that shows why there needs to be another solution to peer-to-peer compute. Because, by the way, smart contracts aren't new, right? They've been around for what, since Ethereum launched? So this isn't a brand new technology here. And why then is open peer-to-peer compute hard? It has to be decentralized, verifiable, and scalable. And the problem is that being decentralized and verifiable without blockchain and without being on-chain is difficult. And so what Fluence is doing is using a combination of a web of trust, quorum, and ZK proofs, and that gives us the scalability so we're not bound by the smart contract constraints, by the on-chain constraints. And we look at the competition globally as, and where we want to compete with, ultimately is Amazon Web Services in the cloud, not blockchain, not smart contracts. And then what do we get? Say, when we're successful and everything is launched and humming, what does that get us? Well, you can then see in an open, transparent cloud what is executed and where and by who, and the code can't be shut off. So that means no closed ecosystems, and any code uploaded can be used and can be built on. That is incredibly powerful. That is, I think, a creativity accelerant because developers can build on other applications, they can build on top of existing code, and that open source authors can share in that hosting revenue because it's clear who is using what code. That's a whole talk in and of itself, but happy to discuss it further. And also, very importantly, it's unstoppable. As long as there is one peer available in the world to serve the code or the application that you're looking for, you can get it. That is hard to underestimate the importance of that feature of open peer-to-peer compute. Now, for Filecoin, why does it matter? Why does it matter for Filecoin miners? Well, because Filecoin obviously is well suited to incredibly large data sets, as we've learned. When you have a large data set, if it's useful data, you're going to need to run computation on it. And computation is easier to run by the storage provider. And storage providers already have this computation sitting there. They've used it to seal. So this unused computation is wasted currently. And so we expect storage providers to have a new model or an enhanced model where they can monetize their unused CPU resources by selling compute services on top of the data that they store. And so the computation can be run locally on top of that data. And if you think about what does that data mean, people here may know better than me, but we're talking about satellite imagery, video, medical data, and what does compute on that mean? It can be removing blurring faces in video. That's computation. It could be moving away clouds from satellite imagery. It could be running studies on data or determining in-out of sample efficacy. Large amounts of potential there and far easier to do on the data where it is and far faster. We're convinced that compute demand is going to grow dramatically. The data on Filecoin is growing, and we've seen those numbers. And the more data that's stored, the more computation will be required. And we think that storage providers are going to be incented to and will actually earn a great return selling their unused computation to these providers. If you think about it, we've already seen auctions for unused storage where there's negative storage costs as there's unused capacity. Well, think about that for computation. You have completely unused computation across the Filecoin network. So you may ultimately get to a place where, quite quickly, where storage providers can offer computation at a minimal price. It probably won't be negative because you have to pay for electricity, et cetera, but it will be by far cheaper than computation offered by the traditional cloud. And when this happens, some of that revenue will be shared with the authors, which will drive usage and creativity and modules and more useful compute on top of that data. And when you combine the storage of the Filecoin network and of IPFS with the compute of Fluence and other providers, you end up with a decentralized cloud. And that is incredibly powerful, and that's what I think we're all working to build. These individual pieces are terrific, but we all need to figure out how to put this decentralized cloud together, because that's the real goal. And so where is Fluence? Fluence is here. We've already launched the peer-to-peer network. We've launched our language Aqua, which basically abstracts out the complexity of authoring and composing peer-to-peer applications. So this isn't a 10-year out vision. This is existing now. And this year we're launching a Swiss Foundation, which is going to be our DAO governance. And next year the compute economy, which will provide the incentives for storage providers to charge for compute, and for software providers to be compensated as well. So what kind of world do we want? Do we want 3 companies controlling internet hosting and content moderated by nation states, with creativity stifled and huge barriers to building independently? We think that incentivized open source is the only architecture that can work. And so I think everyone here wants to support peer-to-peer. And I think that is, the size of this conference and the size of Token 2049 show that there's interest in this. And I just hope everyone recognizes the importance. Why are we doing this? We want to build this because we don't even know the type of creativity that can come afterwards. It's as if someone building the HTTP protocol could imagine Uber. No chance, right? But when we build open systems, the creativity and the applications which can develop are very hard to imagine. And that's what Fluence, what we're trying to do, is to empower developers and empower this next future of creativity. So with that, thank you. Follow us on fluence.network, on Twitter, Fluence_project. Thank you very much.